Module 1, Lesson 20, Comparison Shopping, Unit Price, and Related Measurement Conversions. Now, in the last lesson, we had the same title, but we focused a lot more just on unit rate. This lesson, we are going to see a lot more problems that are involved with unit price. And this is an extension of the last lesson. We're going to be looking at these represented as tables, graphs, equations, and comparing different unit rates that are presented in these different forms. All right, so we are most definitely looking at unit rates in this lesson. And of course, if we're looking at rates, we're looking at ratios, so we're covering all three of our learning targets in this lesson. So I can solve problems by analyzing unit rates given in words, tables, equations, and graphs. So we're taking the last lesson, and we're putting it all to work in this lesson. And we're going to start off in class. We'll have a discussion about the exit ticket from the last lesson. So here is the exit ticket. Chiara, Giovanni, and Ebony are triplets and always argue over who can answer basic math facts the fastest. They sound competitive to me. After completing a few different math fact activities, Chiara, Giovanni, and Ebony record their data, which is shown below. And of course, Chiara has hers in an equation form, and Giovanni has a table, and Ebony has a graph. And we're trying to figure out the completion rate for each student. And we really tried to emphasize last time when we looked at the equations that right here we have our unit rate. So it's 5 math facts per second. And if I take and simplify this down by scaling both of them down, dividing by 5, I find that I've got 4 math facts per second. And here I've got 2 seconds, and that equates to 12 math facts. So I've got a 2 to 12 ratio, and I would scale that down, and I would have 6 math facts per second. So the person who's winning the argument here is Ebony. Ebony is completing 6 math facts every second, while Chiara and Giovanni are both completing less than that. All right, so the lesson today is Exploratory Challenge, which means if we did it in class, or when we do it in class, you and a partner will work through these problems, answering questions. So not a lot of explaining on my part, but I'm going to work through each of the problems and try and do my best to do some modeling of my thinking. So Mallory's on a budget and wants to determine which cereal is the better buy. A 10-ounce box of cereal costs $2.79, and a 13-ounce box of the same cereal costs $3.99. So the question is, which box should Mallory buy? Same cereal, different size boxes. So the real question here is, which is the better price? So we need to get these down to a unit rate. I have a rate here, 10 ounces for $2.79 and 13 ounces for $3.99. And I would like to get these to unit rates, so a per 1 ounce. So I've got $2.79 per 10 ounces, and I would like to scale that down to 1 ounce. So divide them both by 10, and I've got 2 279 thousandths of a cent per ounce, which is about almost 3 cents per ounce. 13-ounce box, so I've got $3.99 per 13 ounces, and I need to scale it down by dividing by 13. And in class, we'll have calculators for this, so if you need to use a calculator, go right ahead. If you want to practice your division, go right ahead. And we'll find out that we have And depending on how we round that, I'm going to round here. So I'm finding out that for Mallory's 10-ounce box, it's costing about 28 cents per ounce. And I'm rounding this to the nearest penny because it's money. We don't usually deal in amounts less than a penny. And over here, I'm finding that the 13-ounce box is about 31 cents per ounce. So I'm thinking here that Mallory needs to buy the 10-ounce box because the difference between the two unit prices is about 3 cents. I've taken that 31 cents and subtracted the 28 cents. And I did that rounding, once again, because we're looking at money. All right, so let's take a look at the next problem here. All right, so Vivian wants to buy a watermelon. Kingston Market has 10-pound watermelons for $3.90. And the farmer's market has 12-pound watermelons for $4.44. So I'm hearing two rates here. I'm hearing $3.90 per 10 pounds. And I'm hearing $4.44 per 12 pounds. And I'd like to scale these down so that I have 1 pound prices. So I need to divide by 10, and I've got 39 cents per pound, and $4.44. Divide that by 12, and I've got 37 cents per pound. So I took the 390 to 10, and I have scaled down by dividing both of them by 10. And I took the 444 and the 12, and I scaled both of them down by dividing by 12, so that in both cases I had a rate per 1 pound, a unit rate. So the difference between prices is about 2 cents. And Vivian probably should go buy the one from the farmer's market because she's getting a little bit better price, assuming that she can eat the 2 extra pounds of watermelon. All right, Mitch needs to purchase soft drinks for a staff party. He's trying to figure out if it is cheaper to buy the 12-pack of soda or the 20-pack of soda. The 12-pack of soda costs $3.99. Once again, I'm hearing a rate, and I've got $3.99 per 12 sodas. The 20-pack is $5.48, so $5.48 per 20 sodas. If I want to compare the prices, I need to get down to a unit rate, a per 1 soda. So I'm going to scale both of them down so that I have a 1 soda. And $3.99 divided by 12. $3.99 divided by 12 is going to give me about 33 cents per can of soda. And $5.48 divided by 20 is going to give me about 27 cents per soda. And so I'm going to suggest here that Mitch should buy the 20 packs because they cost about 6 cents less. Per soda. All right. Mr. Steiner needs to purchase 60 AA batteries. A nearby store sells a 20-pack of AA batteries for $12.49. Once again, hearing a rate here, $12.49, $12.49 for 20 batteries, and $7.20 for 12 batteries. And I'm going to want to scale these down to get to a single battery price per battery. And 1249 divided by 1249 divided by 20 is going to give me about 62 cents per battery. And 720 divided by 12 is going to give me about 60 cents per battery. And so in this case, I'm going to say that he should probably buy the 12 packs because they are 2 cents less per battery. Now, something that I hope you have noticed and that you've figured out is that I'm usually putting the money value on the top, and the other value on the bottom so that I get a per one price. Instead of a per $1 price, I'm getting a per battery price. Something that we frequently do in our society is we find out eaches. How much does one of it cost? Instead of saying how much can we buy for $1. Now there are some things that we do purchase per dollar. I'm thinking, it's fall time, ears of corn. You'll find ears of corn, 12 ears for $1. And so they have it as a per $1 price. But most of the stuff that we buy in our society, we buy per each, per one of something, not per one of dollar. All right, table below shows the amount of calories Mike burns as he runs, and I need to fill in the missing part of the table, so I need to find out exactly how we're scaling here. And I see that, actually I've got a 3 and a 6, and if I combine those together, I get a 9. So if I combine these together, I should get the missing value for 9. But another way to look at it would be the scaling. What are we multiplying the 3 by to get 360? And I'm pretty sure it's 120. And so I would take the 9 and I would multiply it by 120. And I would find 1080. And of course I can double check by adding these two numbers together. Except I don't have any regrouping to do there. And I have 1080. So a few different ways that I can look at this table. All right, so we've done a lot of word problems dealing with money and rates, and now we've looked at a table and worked on some rates. And now we're going to do some comparison between rates that aren't represented necessarily in words. For example, we're back to a table and a graph. So Emilio wants to buy a new motorcycle. He wants to compare the gas efficiency for each motorcycle before he makes a purchase. The dealership presented the data to the right, and the question is which motorcycle is more gas efficient and by how much? So I have to look at these representations. I need to find the rate and the unit rate so I can make a comparison. Well, looking at the graph, I can see I've got a rate of 110 miles per 2 gallons, and I can scale that down to 1 gallon and find out that we're getting 55 miles per gallon. So that goes with this one. I can look at the table here, and I love that there's a 10. I can see 575 miles per 10 gallons, and I can divide by 10. I can scale down to 1 gallon by dividing by 10 and find out that there are 57.5 miles per gallon. So I can say that the second motorcycle, sports motorcycle, is getting more miles per gallon. And I can say then it is more gas efficient. I'm traveling farther on a gallon of gas. And I can say that it is more efficient by 2.5 miles per gallon. The difference here between the 57.5 and the 55 is 2.5 miles per gallon. All right, Milton Middle School is planning to purchase a new copy machine. The principal has narrowed the choice to 2 models, Superfast Deluxe and Quick Copies. He plans to purchase the machine that copies at the fastest rate. Use the information below to determine which copier the principal should use. So once again, I have rates presented in 2 different forms. I've got a graph and I've got an equation. And the question is, which of these represents a faster rate? And the rate that we are looking at is copies per second. Copies per second. All right, well, love the equation. Makes it very easy for me to see if I substitute in 1 second that I have 1.5 copies per second. All right, and now we need to take a look at this graph here. Well, let's see here. If I look here, I've got 36 copies in 20 seconds. And if I divide that by 2, then I've got 18 copies per 10 seconds. And if I scaled in by 10, I've got 1 8/10 per 1 second. So this graph represents 1 8/10 copies per second. And if the principal is basing the purchase solely on the speed, which one copies faster, he would buy the Superfast Deluxe because it copies 3/10 of a copy per second more than the Quick Copies. So it's a little faster. 1 8/10 compared to 1 5/10, we have 3/10 of a copy per second faster. All right, Elijah and Sean are participating in a walkathon. Each student wants to calculate how much money he would make from his sponsors at different points of the walkathon. Use the information in the tables below to determine which student would earn more money if they both walked the same distance. How much more money would that student earn per mile? So Elijah has worked it out where he's going to get $35 for 7 miles. And the question is, how much is he getting paid per mile? So I see that I've got a rate here of $35 per 7 miles. And so I want to scale that down to get to 1 mile. And I find out that he is making $5 per mile. And now we can take a look at Sean. Let's see here. Well, let's take a look here. I've got $66 per 12 miles. And if I scale that down, and here's where it's a little tricky here. 66 doesn't divide very well by 12, so I might have to bust out my calculator. And I've got 12 times 5 gives me 60. So I've got $5.50 per mile. So it appears to me that Sean is making more per mile and is making 50 cents more per mile. Now, making is maybe the wrong word. Earning as part of the fundraiser. All right, Gerson is going to buy a new computer to use for his new job and also to download movies. He has decided between 2 different computers. He has to decide between 2 different computers. How many more kilobytes does the faster computer download in 1 second? So I've got computer number 1, and it is downloading at 153 kilobytes per second. And I've got choice 2, and that is 150 kilobytes per second. Now, hopefully by now we have figured out that this value right here is the rate. But if we haven't, we can stick a 1 second in here, a 1, and find out that we've got 153 kilobytes per second. And we could figure out that we have 150 kilobytes per second. And we can see that choice number 1 is a little bit faster, an additional 3 kilobytes per second. How many more kilobytes does the faster computer download in 1 second? About 3 kilobytes per second. All right, I have no idea. Zirier is trying to decide which security company he will make more money working for. Zirier's commission rate to determine when he will pay Zaire. How much more commission would Zaire earn by choosing the company with the better rate? All right, so we are looking at and comparing superior security and top-notch security. And I love these graphs here because they've both got a per 1. Oh no, though. I have to guess where that 1 is at. So I think what I'm going to do here, because I don't like guessing, I'm going to come up to the 2 here and work with that. And so I can see on superior security that we've got $80 per system. And over here I've got $150 per 2 systems, so I'll need to do a little scaling. Take this down to 1 system and find out that I've got $75 per system. Which means that superior security is paying an additional $5 per system. So how much more commission? $5 per system. All right, Amelia and Miranda are sisters, and their mother just signed them up for a new cell phone plan because they send too many text messages. Using the information below, determine which sister sends the most text messages. How many more text messages does this sister send per week? So here we've got Miranda, and we kind of start to love these equations because we can see that there are 410 texts per week. And Amelia, we've got to do a little scaling. So I think I'll just grab this one right here. 1,200 texts over 3 weeks. Scale this down to 1 week. And I'm going to find out that there are 400 texts per week. So the sister who is sending the most texts is Miranda, and she is sending 10 more texts per week than her sister, Amelia. All right, so what did all of the problems that we worked on today have in common? They all involved unit rates. The information was provided in different forms. We had word problems, we had graphs, we had equations, we had tables, we had unit rates represented different ways, and we had to pull the information out so that we could make comparisons. Now, hopefully a few things that you have observed as we have worked through the last couple of lessons. When we have a table, the unit rate is the value of the first quantity when the second quantity is 1, so we have to scale down to a per 1. In graphs, the unit rate is the value of r at the point 1r. So when we go over on a graph to 1, whatever the value of y is, we've got our unit rate, r per 1. The value of r at the point 1r. So we go over and we go up. So we go over to 1 and we go up to whatever the y is, and right there is the rate. And in an equation, the unit rate is the constant number in the equation. So right here, that is our unit rate. Hopefully these are things that you have noticed and figured out as we have worked on these for the last couple of lessons. All right, so hopefully you are feeling really comfortable solving problems by analyzing unit rates that are given in words, tables, equations, and graphs. We did a lot of comparison between the two. We did a lot of finding just the unit rate, a lot of scaling, a lot of reading graphs, putting together a lot of different things that we have worked on with ratios and rates. All right, so learning target. Hopefully you are getting really good at identifying what a unit rate is. Hopefully you remember that these do connect to our ratios and equivalent ratios. So this concludes Module 1, Lesson 20, kind of a fun exploratory activity. We've worked really hard to get to the point to just be able to solve problems. So make sure you go ahead and complete your problem set, and if you've got questions, talk to your teacher.